Hello, in this video, you will learn the working of complementary symmetry class B amplifier and the formulae to be used for solving the problems. A complementary symmetry class B amplifier uses two transistors, one NPN transistor and one PNP transistor, and they are connected like this. So this is an NPN transistor and this is PNP transistor and this is the emitter. So the emitter of NPN transistor should be connected to the emitter of PNP transistor like this, and the center point is connected to load, and other end of the load is grounded. So this is RL, and the collector of NPN transistor should be connected to plus VCC, and the collector of PNP transistor is connected to minus VCC. So in the basic circuit, we are not using any biasing circuit, and we are just using a coupling capacitor for both transistors like this, and these two ends are connected together and the signal is applied here. This is the signal voltage. The signal is like this. This is T. So this is Vs, that is the input voltage. During the positive half cycle of the signal, this point is positive. Since this is NPN transistor, when the base is positive, this transistor will conduct. This is transistor Q1, this is transistor Q2. So during the positive half cycle, Q1 will amplify and the current will flow in this direction. So the output voltage will be like this. So during positive half cycle, since this point is positive and this is PNP transistor, so any positive voltage given to the base will not provide any current in the collector or emitter of Q2. So Q2 will be off. Only Q1 will be conducting. So Q1 on, Q2 off. During negative half cycle, this point is negative. Since this is NPN transistor, Q1 will not conduct, and during negative cycle, this is PNP transistor, we are giving negative voltage to the base, so Q2 will be conducting because it is base is N-type semiconductor. So when you give negative voltage, Q2 will be conducting. But the current direction will be like this because this is minus VCC point and this is ground. So the current will flow from higher voltage to lower voltage. So the current direction will be like this. That is, in the load resistance RL, current will flow in opposite direction. So when Q1 is conducting, current is flowing in this direction. But when Q2 is conducting, current is flowing in the upward direction. So the output voltage produced in this case will be in opposite direction. And again for the positive cycle, it will go like this. In this circuit, when you give positive voltage, the transistor Q1 will not conduct immediately because there will be cut-in voltage 0.2 or 0.3 volts. If the input rises beyond 0.3 volts, then only Q1 will start to conduct. Similarly, during negative cycle, Q2 will conduct if the negative voltage goes below minus 0.2 or zero point 0.3 volts. So, this is the output voltage. If this is zero point 0.3 volts, there will be no output current up to this point. So, the voltage will also be 0 here. Similarly, when you are coming to this point, during this period, the voltage will be 0, and in the negative side, again up to this point, the output will be 0. So here also output will be 0 up to this point. So the actual output will be like this only. So when the output voltage crosses the 0 axis, there is a gap, that is a non-conducting period. So this is called as crossover distortion. This is happening because of the forward biased junction here and here. To avoid this, you can bias these two transistors using a resistor like this. Similarly, this transistor can be biased using a resistor like this. And here you have VBE, here also you have VBE. So you can connect two diodes like this. So by connecting two diodes like this point is kept at above 0 volts, and it depends on the cut-in voltage of this diode. Similarly, for this diode, another 0.2 or zero point 0.3 volts. These two diodes will take care about that crossover distortion. In this topic, problems may be asked to find out DC power, PDC, and that can be found using 2Im by pi. This is the DC current into VCC. And Im is equal to Vm by RL. Vm is equal to VCC. And maximum AC power in the load can be given by 1 by 2 VCC square divided by RL. And power dissipated in the transistor PD is equal to PDC minus PAC. Then maximum power dissipated PD maximum is equal to 2 by pi square into PAC maximum, and percentage of efficiency is equal to PAC by PDC into 100.